Hey everybody, welcome back, and today we're getting right back into more speaker upgrades, and hopefully I can make it through this one without having to stop. My throat is sore, but I'm feeling fine. So let's see if we can get through this. First of all, over my shoulder here, the Clearwave. That was one that came in a couple of weeks ago. It was an all-active speaker, and now it's not. Now it has a really well-designed passive filter that produces a really nice smooth response. Yes, there are advantages to getting those electronic crossovers out of the signal path and going to a real high-quality passive filter. The other speakers that have been in this week have been Magnepans, and I'm going to try to dedicate the rest of this episode into talking about a couple of the Magnepans that came in and the upgrades that we've done for those, and how to go about upgrading the Magnepans. We have a lot of customers out there that own the Magnepan speakers, and they use with them our open baffle servo controlled woofers. They match really well with the Maggies, better than anything else out there. They're fast and well controlled and can keep up with the speed of the Maggies, and the controls and functions on the servo amp will allow you to do anything. And they play flat to 20 hertz, so bottom end like no other speaker. They blend perfectly with the Maggies. And if you're a Maggie owner, if you've upgraded the crossover parts and you've set them up properly and you've set your room up properly and you've got them out into the room, you can get and good electronics with a big amplifier. You need a big amplifier that'll deliver some current if you're driving the Maggies. If you've got all that, you can get some really good sound out of those speakers. I mean, across the board, all their products can sound really good if you take those steps. Now, from the factory, they do come with very budget level parts. And most of the Maggie owners out there know you can start going through there and upgrading those parts, and you can really start making some improvements. I mean, big time improvements. This week we've had the 1.6s and 1.7s in here. Let's start with the 1.7s. Now, in order for me to get some good measurements on these, I usually start measuring them at different distances. You can't just do a 1 watt, 1 meter measurement on a Maggie. It's too big of a speaker. You need to be much further away. So I'll go out 2 meters away or more, come back in. I'll look at it with a gated time window. I'll look at it with the allowance of the floor reflection and try to get a good feel for what it's really doing. These are the measurements. I'll have this one popped up here, the 1.7s. This is a measurement of each of the 2 speakers. Just swapped them in and out, same position, took back-to-back measurements on them. Yes, they had a much heavier bottom end. It is kind of jacked up in the bottom. The rest of the response is much lower in output. I thought, well, this can't be. This just doesn't look correct at all. Maybe it's my measurements. So we set them up here in the shop and just hooked them up and started playing them and listened to them. And they sounded just like they measured. Where are all the highs? What's happened to these things? The next thing I had to do was take one of them, turn it upside down, take the legs off. You have to pop all the staples out across the bottom of it and get the sock to slide down. And there's some wood inserts down the edges. You have to pull those out and open them up. You have to be careful not to break that stuff and move it open to where you can slide it down. Then you can reach in and disconnect the crossover and connect right onto the drivers themselves, and then I can start designing a new crossover for it. I do need to tell you guys, when you're tearing into these things and you look at the connections on the Maggies, they're not labeled at all. There's no plus and minus anything anywhere on there. So once you start getting into it, you're going to have to figure it out. You're going to have to trace the traces, look at which traces are going to the mid panel, which traces are going over to the tweeter element, and figure out what goes where. And another thing too is they typically use a reverse polarity on the tweeters on most of the Maggies, so you're going to have to keep that in mind as well. Now the 1.7s had 2 elements on the tweeter, In other words, two tweeter elements, or you'd think of it as maybe a dual voice coil type situation. And it looked as if they may have been crossed over differently, and the top end they were in parallel. And that caused a problem as well. I mean, you pull up the impedance curve on the Maggie 1.7, and I want to say it dropped to 1.9 ohms. So pretty low impedance curve at the tweeter top end, and then at the mid panel range it was 3.7 ohms. So if you got these things, you better have an amp on them. And the other thing I've noticed with the Maggies in general, when you get enough power on them to really push them to good levels, you start to stress the tweeter, and you can hear it in the way it sounds. The tweeter begins to sound stressed. And my solution to that has been to design a crossover to where it's a second order filter on the tweeter instead of the first order crossover that's allowing it to play down so low. So putting that second order on there balances the response really well. Everything's in phase, keeping with the first order on the mid panel, and everything blends really well. So what I did on the 1.7s, I will let you guys check out the new measurement of the 1.7. I used a large enough inductor on the mid panel to pull that level down and balance it out. The tweeter is playing out there to where it was before, but then you'll notice the tail end of it drops off rather quickly, and it doesn't continue to extend out as far as it did. So a lot less strain on it, a lot smoother response. Now when you guys do this to the Maggies, you're going to have to series the elements in the tweeter. If you don't, you're going to wind up with too low of an impedance curve if you parallel those two things. So be sure you series those two. You're going to have to figure out which one is positive and which one is negative, and you're going to have to jumper from the positive of one to the negative of the next to run them in series. Do that and it works fine. Now of course I had the advantage of taking an impulse response and seeing which way it goes. If it goes up or down, I know which way the polarity is. So it was easy for me to correct it, or to check it. And then what I did with it is on the elements, I marked them, which ones I wanted wired positive, which ones I wanted to wire negative, so that the customer could then hook it up pretty easily. If you get the wiring wrong, if you get the tweeter out of phase, what's going to happen is the drivers are going to cause a big hole in the response. When they're out of phase, they're just going to cancel and be a big hole right there in the response. If you hook up a new crossover like I've designed on these and you hear a big hole, you know that the tweeter polarity needs to be flipped. So simple as that, easy to fix. The other issue, and it's the same with the Maggies across the board, little terminal cup or terminal plate on the back of them needs to be done away with. Those connectors on them are ferromagnetic. There's a fuse in the signal path, obviously to try and protect the tweeter from overdriving an amplifier on it or something. But that's eaten into your sound quality as well. You can do away with it, and you can get away with it with the second order filter that's on it, because you're protecting it a whole lot more than it was. But you'll still have to be careful with it not to try and just completely overdrive it. They're only going to play so loud. The sensitivity is pretty low. What you need to do is take that plate off and build one out of wood, MDF, something like that, paint it black, put a set of tube connectors in there. Now you've done away with all that junk that's in the signal path. Rewire it with good quality wire. Now you're looking at huge improvements. And the customer that just built out these 1.7s is loving it. Says it's unbelievable how much better it sounds. And that's just the way it is when you get that stuff out of the signal path. Put good quality parts on there. There's two 16 gauge air core inductors on it. One on the tweeter, one on the mid panel. It's a much higher quality inductor than what was on there. It's a bigger gauge than what was on there. And then one Sonicap. That's it. That's all there is for parts on it. So all total, all new parts, new wiring to connect everything with, and a set of tube connectors, $278. So for $278, you can really improve the Maggie 1.7s. Now, the Maggie 1.6s, they were in the same boat. Same thing applies. You have to undo all the little staples on the bottom, undo the little, I guess they're little finishing nails that are in the little wood trim down the side, pull those out, slide the sock down, and you can get to everything. And this is the measured frequency response on the 1.6s. As you can see, tweeter's playing down really low. The 1.7s, the tweeter was playing down really low the same way. I didn't really change how low it played so much as I changed the slope on it so that it protected it a lot more. I did the same thing with the 1.6s, put a second order filter on the tweeter to allow that thing to just drop off a lot more quickly and keep it out of that range. The owner of these also mentioned that when you get a lot of power on them, he always heard a stressed sound. That's a tweeter. That's a tweeter playing down too low. So the Maggie 1.6 only has a single element or a single voice coil on the tweeter, so you don't have to worry about trying to match those things up and get them in series. And the impedance also was pretty low on those. And on the Maggie's 1.7, once I was through, the impedance came up to, I think, 4.4 ohms, and it was balanced all the way across. So a lot easier load after I was done with it. Same with the Maggie 1.6s. I pulled that response down at the lower end that was jacked up, brought it down, balanced it. So now a lot more balanced sound. So now your highs don't sound like they're 8 or 10 dB down. Now everything is balanced with it. Same thing, 2 ERSI air core inductors and a sonic cap. That's all there is to the whole circuit. The impedance is, like I said, it's an easier load. You're above 4 ohms. And total cost on all the parts for the 1.6s, all new wiring and a set of tube connectors, came to $232. So it's not a lot of money to go in and upgrade those models. You're just going to have to be a little patient with undoing all those staples, sliding everything down, pulling out all the old parts, putting a board in there for the new crossover, mounting it in there, wiring everything back up, sliding the sock back over, restapling it across the end, putting the end pieces back in. It's a little bit of work to get to everything and to get it done, but in the end, it's an amazing transformation of those speakers. If you liked them before, you'll really like them after doing that upgrade. So if that's something you're interested in, shoot me an email and we'll get you fixed up. That's going to be it for this week. Thank you everyone for watching. Thank you for subscribing. If you haven't subscribed, click the subscribe button, and we'll be doing some more fun stuff next week and the week after. I've got some really good things in the works, and I can't wait to share them with you guys. So stay tuned. Have a good one.